N8n is a low-code tool, not a no-code tool. So if you're willing to get your hands dirty, you can do some very powerful things with its built-in JavaScript functions. This is the tutorial for string functions in N8n based on Nick Saraev's N8n Mastery course. In order to follow along with this tutorial, create an edit fields node on your N8n canvas. You'll create a field that has any name, make it a string, and then we're going to do all the demonstrations of the different string functions inside the value for your variable. Click on expression, and then click on this little arrow on the bottom right that'll open up a larger canvas for you to work in. There are multiple string functions, and in order to see them, you can get a little pop-up. Just first of all, create two curly braces, and then inside the curly braces, create double quotes and put anything, including nothing, inside them and click a dot. And this is going to give you all the string functions that are available inside N8n. So we're going to go through each of the string functions so that you can learn all the powerful things that you can do with them. First one is includes. And what you'll see is over here, I have number 1, and then over here, I have number 1. So this output is the introduction portion right here. My string includes quote, my quote. And then inside the curly braces is the JavaScript that we're executing. So we've created a string called myString, and the dot includes is the function that we're calling. And inside the parentheses is the argument that we're asking the JavaScript to evaluate. So in this case, what we're saying in English is, does my string, quote, my string, does it include the letters capital M, lowercase y? And the answer is true. So you get back what's called a Boolean true, Boolean being yes or no, 1 or 0, true or false. And that's saying, yes, it does include it. So when you get back a true value, notice that true is not in quotes. Boolean is expressed without quotation marks. So it's returning a Boolean, but what we gave it was a string. We actually gave it 2 strings. One was the string that we're inquiring about, and then inside the parentheses is the inquiry details. So the question is, does my string include my? And the answer is true. Yes, it does. The split function enables us to take one long string. In this case, let's put this on another line so you can see it. Quote, my string \n, my other string. And the request is to split on \n, which is the escaped way of saying new line. And by escaped, I mean that the N stands for new line and the / says, please don't interpret this as an actual letter N. Please interpret it as a command. And the command is go to a new line like that. So in this case, what we have is this string. We have the string my string / my other string. And the result we get is my string, comma, my other string. So it's creating a comma separated list for us from our input. The output is the different pieces of the thing that we split separated by commas. The next function is startsWith. Does my string start with a capital M? True, it does. The next function is replaceAll. We're going to replace all instances of string with the string what ? So we turn my string is probably my string into my what is probably my what, where this what is, let's do this again. So we replace all instances of string with WHAT ? So the first argument is what do you want to do to the string or find in the string, and the second argument is what do you want to replace it with? That's going to find all instances of string. So this my string is probably my string. There are 2 instances, and we get 2 whats. in our reply. 5 is length, and there is no argument. It's just going to return an integer representing the number of characters that are in the string that we're asking it to operate on. Number 6, base 64 encode and base 64 decode. Number 7. 6 says, here's something called my string, and I want you to reply with base 64 encode. And here's something called my string, and I want you to reply with base 64 decode. I'm going to leave it there because my knowledge of base 64 and of encoding and hashing is not enough to add anything to this conversation. If you want to use these, unless you're given specific instructions or you are in fact a programmer, then it's enough to know they exist. 8, extract domain of the Carol report at gmail.com. So the domain that is embedded in this string, if it can find one, is gmail.com. If I changed the argument here to the carolreport.comx, it would come back with com. So it finds the thing that is the pattern of a domain. If I just said com without a period in front of it, it can't find the standard pattern of a domain, but when I put the period in, it does find the standard pattern. Number 9 is extract email from a string. So the string is the carolreport@gmail.com, and the email extracted is the entire string because the entire string is an email. But if I put in a giant document, would help if it was inside the quotes, it still would come back with just the carolreport.com. That helps a lot if you're scraping for leads. Number 10, extract URL. Even if this is a giant document full of stuff in front of the carolreport.com/freeai tutorials, it's going to reply with the part of the string that is a URL. HTTPS : begins that string. So it finds that pattern for you. Extract URL path finds the path portion of the URL. So that would be everything that's not the URL, but the URL path that is after HTTPS and then the domain and the top level domain.com. Number 12 is hash, and in this case, and number 13a is base 64, and 13b is base 64 decode. And these are also like the previous base 64 encode and base 64 decode that we looked at. Either you're given explicit instructions on how to use these, or you're already a programmer and you know how to look up the fine details, because you're going to use these to do things like store passwords. But what I wanted to show you is something called stringing functions, where you're going to append, here is a string, and we're going to hash it, and the argument is base 64. And then we're going to take the result of that, and we're going to base 64 decode. And what happens if you look at the output is first it takes my string and it creates tkx equals, and then the decode returns it to the original string, which shows you that it's a finite pattern that it's operating on. Number 14 is quote. It's going to, in this case, you have something that you need to know about if you're going to muck around in strings. This is really helpful. You see how I have single tick quote, and then I wrote, my father said, quotation, double quote, hello, unquote. When you want to quote a string inside another string, you can use single ticks to denote your outer quote and double quotes to denote your inner quote. And when the .quote function operates on that, it takes the exterior quotes and it puts a backslash in front of them. That escapes the quotation mark, which means we're asking the code interpreter not to interpret this as an actual quotation mark, but as a literal quotation mark. In other words, it is not part of an argument that says I'm the beginning of a string, I'm the end of a string, go ahead and consume me. It is the beginning of a literal quotation mark that I want you to just carry forward and then render later as a quotation mark. But don't treat that as an argument to the function. Number 15 is remove markdown. So if you get markdown back from an LLM for content creation, for example, and you don't want the pound signs and the asterisks in that content, you can say remove markdown, and that will take the pound signs and asterisks out. Number 16 is remove tags. It's referring to HTML tags. And over here you could see that my becomes just MI, like it did with the markdown. Number 17, replace string. This is like replace all, except in this case, replace only replaces the first instance that it finds. Replace all replaces all instances of string with what, whereas replace replaces just the first instance. So my what is probably my string. String got replaced with what question mark on the first instance, but on the second instance it did not. Number 18 is replace special characters. We're going to feed it the accents in the word déjà, and it is going to remove them. So if you're having problems with some data set churning out bad characters that look like blocks with question marks, you might need replace special character. Slice is a position-based parser. So what we have here is I am 10 characters, and then comma, and then 10 characters am I. So 2 strings for a total of 21 characters. This one is 10, this one is 10, and the comma is 21. So if you slice this at position 11, starting at the 0th character, you're at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The comma is 10, and the number 1 is the 11th character. We're going to slice this string at position 11, and if you look at the result, it is everything from the comma onward, 10 chars am I. If you slice from the 0th position for 10 characters, as in number 20 here, it slices everything from 0 through 10, which is I am 10 chars, up to but not including the comma, 10 characters. Number 21 is index of. What this does is it helps you find strings within strings so that you can then slice or otherwise grab chunks of string out from entire long strings. So in this case, what we're saying is I want you to tell me what position the comma is. And we know it's at the 11th position because we counted 10 characters, but we're starting at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th character, when you're starting at 0, is the comma. And if you go to 21, the comma is at position 10. Number 22, we're going to grab the substring of the I am chars, comma, 10 chars am I, starting at 11 and going to 26. So 26 is a position, not a length. If you've coded in the past, you, like me, might think that's a length. Substring in this case is a position. I want you to give me the 11th through the 26th character, which is the second string, 10 chars am I. 23 is to JSON. This is the same as we saw before with the outer quote being a single tick in order to include double quotes inside it. So we're going to ask to JSON string to accept as an argument or as the thing upon which it operates, tick quote, protect the string, quote tick. And the output of that is to escape the inner quotes. So it gives us a quoted string, and any quotation marks inside the string are considered literals because they have a backslash in front of them. This prevents the code interpreter from assuming that it should consume those strings as arguments. It doesn't, if it's looking for a string and it gets to the end of a pair of quotation marks, it's going to assume that's the end of a string. So if it were quote without the backslash quote, it would consume quote, quote, and then it would stop. By putting the backslash in front of that second quotation mark, it knows, the code interpreter knows to continue reading. It doesn't take the second backslash quotation mark as an end point because it's escaped with the backslash. And then it sees the second quotation mark. It says, okay, I'm done reading. I have found my second quotation mark. 24 is trim, and trim There's an extra space before the M and an extra space after the Y. It does not care about extra space inside a string, but it will trim will trim this extra space and new lines, any kind of white space character, new line, tab, space. It will trim it from the ends of the string. So in this case, it's going to give us my string has spaces. It's going to remove the extra space from before and after that string. When we say trim end in 25, see the extra space in front of my in the output? Trim end only trims the \n, the new line, from the end of the string. It's trimming the end. When it trimmed the \n, it was left with another piece of another character at the end of the string that was a white space, and so it trimmed that too. So there's no white space at the end of this string, not a space and not a new line, but there is still one at the beginning of the string. 26 is trim start, and that's going to take a space at the beginning, any space at the beginning, but not trim the space at the end. And so 26, actually, you can see how there's an extra line here. Look at 26, trim start. The argument is space \n being new line character. There's no space at the beginning of the output, but at the end of the output, there's a space after the S and a new line right there. And that's coming from the fact that it's embedded in the string, and we did not escape it by using trim or trim end. We used trim start, which only trimmed the start of the string. URL encode is a way to send URLs across the internet without pesky spaces screwing things up. 27 shows that, not just spaces, hyphens and other things that could be misinterpreted. So what's happening with this one is the colon is turning into something called an entity. %3a is the entity. Slash is %2f, and there are two of them, so %2f, %2f. So when we're sending data across the internet, in order to avoid colon or slash being misinterpreted, they're reimagined as these entities that are agreed upon between all the internet senders and readers, that if you see %3a, when you interpret that, you can look at number 27 or 28 URL decode, and it'll come back as : //. So when you see % and two letters, you know that it's URL encoded, and that you can URL decode it to get the value that's more human readable. 29 is ends with, does my end with y, and 29 is true, it does. 30 is my includes cap M, and the answer to 30 is false. If we put lowercase m in there, we would get true. 31 is last index of. This gets us a substring counting from the end of the initial string that we're operating on. If a substring is in the major string more than once, you will get the position of the last instance. So in this case, the string is my hovercraft is full of eels, comma, do you have any eels? Eels is in there twice. The last index of eels, 31, is at 47, which is all the way over do you have eels. This is the 47th character starting from 0. But if you do an index of eels in that same string, you see that it gives us a 25, because eels is at 25 right here, and that is the first instance. So index of gives you the first index position starting at 0, and last index gives you the last position starting at 0. Next, we have search, which involves using regular expressions, and it is a subject in and of itself. So this is the simplest example that I have found. If you come across search, you might be able to substitute index of for a much easier time of it. In this case, what search is saying is, find everything between this first slash and this second slash and tell me the position. Same as index of. It's just that it's a lot more powerful because it has tons of operators that allow you to make finite distinctions between one character and another. Next, we're going to look at is domain. So here we have a string that is the letter M is it a domain? 33, 2 going on here. In the first one, 33, M is domain is false. M.com as a string is domain is true. Similarly, number 34 is email. M as a string is email is false. M at m.com is an email is true. 35 is empty. M as a string is empty is false. A simple set of double quotes with nothing inside it, anything inside it is empty is true. And 36, M is not empty is true because it has something in it, whereas a single set of quotes, 36, a set of single quotes is not empty is false. It is empty. 37, this converts, is numeric converts a string to a number. If you did convert this character to a number, would it be a number? Is what is numeric does. 37, M is numeric is false, but 1 as a string is numeric is true. And we'll see how to use that in just a second. That number 47 is when we'll see that is numeric. 38 is URL. M as a string is 38. False, it is not a URL, but m.com as a string is URL. It is also not a URL, but the third one, http://m.com is a URL is true. 39, 40, 41, 42, and 43. To lowercase, to sentence case, to title case, to snake case, and to uppercase. So 39, you have all caps to lowercase becomes all lowercase. 40, all caps to sentence case becomes an initial capital letter followed by lowercase. 41, to title case, each first character of each word is set to uppercase. 42, snake case, regardless of whether the input is lowercase or uppercase, it all becomes lowercase with an underscore in between each word. So there are no spaces. 43, to uppercase, changes everything to uppercase. 44 is parse JSON. So what it's doing is creating an object, which unfortunately we cannot see in our output. But when you need to pass a JSON object as input to a node, you'll know that parse JSON exists. 45, Boolean, we talked about at the beginning of the video. If something is Boolean true, it is 1 or exists at all. The fact that it exists means true. And it evaluates to 1 or true. And Boolean false evaluates to 0 or false. So M as a string, when you convert it to Boolean, is true because it exists. It doesn't matter if it's 1, it exists. It is a positive thing. It is not nothing. 1 as a string to Boolean is true, and tick space tick, where space is the thing that exists, is Boolean true because the space exists. On the other hand, 0 to Boolean is false. An empty set of ticks with single quotes is false, and a string that's made up of empty double quotes is false. 46 is date time, and let's go through each of these. So when you change 05/05/2025 to date time, you get the literal bracket date time colon and then this string that includes the year, month, day, and the time zone, the time, which is hours, minutes, seconds, milliseconds, hyphen, and then the hyphen is a minus sign, the number of hours you are behind UTC. If you are in my locale, which is US, the first 5 in 5/5/25 is the month, which you cannot see here because this could either be month, day, or day, month. They're both 5. So if you look at 06/05/2025, this is month and this is day, and we can prove that by going to, let's say, 13. So we know that that is the month column, that the first column is month, because if it were a day, it would be an acceptable character. So if I put 05/13 here, where my 13 is in the days column, then we know that I'm in a locale on my computer where the second entity stands for day. In the third example, 0525, including the time, which is the minute, the hours, the minutes, and then the seconds. Date time will turn that into date time 2025-05, and then T for time 11:15:33, and then dot for the milliseconds, and then -4 for hours behind UTC. You can use lots of formatting arguments to change the date into something more palatable, like for auto-constructing an email. So what we're doing is we're stringing the function format onto the date time here. So it's the string.toDateTime, dot format, argument, where the argument in this case is FFFF, and that stands for Sunday, May 25, 2025 at 11:15 a.m., and then it spells out Eastern Daylight Time. Then the next one is formatting MMDDYY, so we get 5/25/25. And the next one is the format of CCCC, which gives you the day of the week spelled out. Now, 47, this shows you the difference between a string and a number. If you add, using a plus sign, a string plus a string, then you concatenate the strings. In other words, you string them together. You append the second one to the first one. So 5 plus 5 is 55, and 55 is a string. But if you say 5 to number, this 5, that's a number, is usable in math. And you can see in the next example, 5 to number plus 5 to number is equal to 10. Whereas string 5 plus 5 is 55, number 5 plus 5 is 10. You can also use to number to translate scientific notation into something that is no longer compressed. And then you can also dot format that same function to add the commas or periods that are correct for your locale. So that is string functions in N8n based on Nick Saraev's N8n Mastery course.